Right, here we are again. Now going to try looking at one-hotting the data. This is Python Notebook 02B. You've done this enough times, I'm not going to talk about it. For H2O and LightGBM, we don't need to one-hot these variables. That is something we will worry about much later on. What do we need to do? Create vars int categorical, a list of categorical variables. Let's follow the hints. We're told that df_all dtypes gives a pandas series. Yep, it definitely does. What is this thing? Is it a series? Yes, it is. Which of the elements of this series are an object, which means a categorical variable as far as we're concerned. That works, you get true and false. Now, df_all columns gives an index of the column names, if I spelt it right. And the above index can be sliced, we're told. Well, let's slice it then. And we want it to be a list, to list. That works. You can see these things, the alley, the lot shape, the land contour, the subclass, they are all clearly categorical variables. What is the cardinality of these categorical variables? Hopefully you gave that a go yourself and you found some kind of function in pandas which tells you how many unique values there are to each. I suppose, to be fair, I might not have been very clear when I said cardinality. Do you remember we were looking at roof style before and we were using 3 of the roof styles? You can see here, in fact, there's 5 different roof styles. The main thing we need to realize is that when we one-hot categorical variables, we get a new column for each unique value of that categorical variable. If there are 5 roof styles and we one-hot roof style, we will get 5 new columns. So I'm looking at the cardinality here to make sure none of these have too high a cardinality. High cardinality categorical variables need to be dealt with specially. If you were, say, looking at postcodes in the UK, from memory there are about 10 million different postcodes. We wouldn't want 10 million very sparsely populated columns of zeros and ones in any data set. But looking down here, there's nothing which is too massive. The highest cardinality is 24. I don't really mind having 24 columns, and altogether it looks like we might get, I don't know, 100 new columns. That's not too bad. What are the various roof styles? Well, rather than typing n unique, if you just type unique, you get the different roof styles. And what are 5 of them? From 15 to 20, you can see hip and gable. How do we one-hot variables? Well, unsurprisingly, there are a million ways you could do this. You could write it yourself without too much difficulty. You can use pandas and you can use sklearn. Let's just have a look at pandas. In pandas, it's called get dummies. Let's have a look carefully at what's going on here. If we do drop first equals false, then you can notice we've got 5 columns. If we do drop first equals true, we've only got 4 columns. And I asked what the difference is. Well, that wasn't very hard, was it? The difference is that if you do drop first equals true, it drops the first one. If you remember, when we went through this on the video, we couldn't have all 5 in traditional linear regression. The matrix would be non-invertible, the model would be not uniquely determinable. We would need to do something like drop first. Well, there's some kind of questions here which you should be able to answer. If we one-hot every level of a categorical variable, is it well defined? No, it isn't. Should we drop first when creating dummies? Well, that's a good idea. There are alternatives. But as this all relates to traditional linear regression, we're not really going to go into it. Incidentally, long before data science was even a buzzword, statisticians had faced exactly the same issue when they were doing linear regression. They just didn't use such fancy words for it. They talked about contrasts and things like treatment contrasts, but doesn't one-hot sound so much more impressive? Should we drop first when creating dummies? Yes, we have to. What is the impact on linear regression if we drop first? Well, to the best of my knowledge, there's no impact whatsoever. What is the impact on tree-based methods? Well, we haven't discussed tree-based methods. We will do later, but basically don't. Don't do drop first if you're using tree-based methods. That would not be a good idea. Now, Rather than using pandas, we are going to use sklearn. Okay, what a palaver. It has been about 3 hours since I recorded the first part of that video. Then it all started going really badly wrong, and it took me a while to figure out. Basically, the container that we're using has scikit-learn version 0.19, and the one-hot encoding which is in there only works on numbers and not on string, which is really surprising, and it's a complete pain. More recent versions do more sensible stuff, but I would prefer not to mess around with the image underlying the container that we have. So rather than do this in sklearn, we're going to continue doing it in pandas. Now, if all we wanted to do in pandas was to drop the first column, there would be a very easy way of doing all of this without any loops, and I've written out at the end, but I actually think it's worthwhile going through this the hard way, especially for those of you that aren't familiar with everything in Python and pandas. This will give you a few ideas. So first of all, we're going to create a copy of dfall and call it dfall one-hot. So here we go. dfall one-hot equals dfall copy. If we didn't do copy over here, and we just did dfall one-hot equals dfall, we would just have two variable names, dfall and df1hot, pointing to the same object in memory. And if we made a change to dfall one-hot, it would change that object in memory, and so dfall would also be changing, because it refers to exactly the same object. Choose a column name. We're going to choose ms subclass. Now, create dummies for that column using pdgetDummies. So here's the function we're going to use. dfall col is actually picking up ms subclass because col is subclassed. Drop first equals false. We're not dropping the first because I would rather drop the most frequent column. There is a reason I would rather do this, but I'm not going to go into that now. But let's just say it can be sensible to drop the most frequent column. What does dfoh look like? Let's just run that. There we have it. It doesn't look very exciting. These are the various ms subclasses that we have. Now, what is the sum down each column? I hope you can figure that out for yourselves. Each row represents a house. A 1 in a particular column means that that column is that particular subclass. So these 4 houses over here are subclass ms20. If we sum the columns, we're going to get the total number of houses for each particular category. So we were looking at ms20 there, I think. There are 1083 houses with subcategory ms20. Now somehow we want to find the most frequent one. Hello again. Would you believe I was just in the middle of editing that video and somehow I lost the rest of it. So we're going to record this clip for probably about the 5th time in one day. I think we were up to here. We were just about to find the most frequent column, which should be ms20. We can use something called idxmax. There we have it. That gives you ms20. Once we've got ms20, we can now drop that most frequent column. It's gone. I should point out that although we've dropped ms20, we still know, looking at this data, if the property is in zone ms20, because all the other columns will be 0. So in some ways it's possible to make a linear combination of these other columns to find out whether it's an ms20 property or not. Change the column names so that we have the original column name as a prefix with an underscore, and finally concatenate everything. If we do look at the head of this, we now see that at the end you have all the ms subclasses. All we need to do therefore, now that we've prepared this, is a little loop which does everything. In this data set, in this notebook, which I'm using just to re-record this last bit, everything is filled in, but you would have had to literally just cut and paste from above. Number 1, get the dummies, don't drop the first. Next, find the most frequent column, then drop the most frequent column, change the column names, concatenate the data, and over here we are extending a list with the new one-hot variable names. So we will have and we will save a list of all the one-hot variable names, which is going to be useful later. How big is our new data? It's now got 220 columns instead of the original 80, so it's already quite wide. That is probably going to cause some problems later on when we try doing traditional linear regression. What are the data types? Well, we only need to store a 0 or a 1 in all of these data types, so pandas has been relatively sensible. It's used an unsigned integer, 8 bits. I think it could have gotten even smaller than that, but whatever. Here's the code, but if we wanted just to drop the first each time, we wouldn't have needed to use a loop at all. And finally, again, this is filled in already for you. Hopefully you managed to do it yourself in any case. We're creating a random number generator. We are then generating random integers between 0 and 10. That does not include 10, so there are 10 random integers. Every house in our data will now be assigned a value of fold, which is 0 through to 9 inclusive. We can use this fold variable later on to divide our data into different pieces. We might, for example, want to train models only on part of our data, and then we can see, using the rest of our data, if our model can predict well on data it has never seen before. That's it. Oops, folder is not defined. What happened there? Now it is. Oh, by the way, please note, I fixed the random state, otherwise we would all be working on different data and that would be sad. Save the data. Notice this dictionary is now a bit bigger. I've used it to save the new one-hot variables, which is going to be useful later on.